G'day, this is Matt Cornell from Cornell Engineers. Today we're running a case study. It's a property that's subject to overland flow, water's coming in from a neighbour's property, causing a bit of water ingress, ponding on the site. And today I wanted to go through what we look for as engineers and go through some of the ideas for improving and fixing the problem. This particular site has already had the benefit of a number of inspections from some plumbers and a landscape gardener. All of these quotes have some good ideas. Let's jump in and work out what the best way we think is to fix these problems. So let's start with identifying what the problem is. This is this person's yard when it's dry and sunny. You can see there's a low rock retaining wall, a concrete slab on the right hand side. Maybe that's a water heater, and an area of gravel beside the boundary fence. Water comes in from that side and floods into this gravel through this retaining wall and onto this slab. Let's have a look. The gravel path now is full of water. The concrete pathway is already fully flooded and water is spilling through the retaining wall and has totally fully filled up the area between the retaining wall and the hot water system. So on the other side of the fence, it doesn't look too bad, does it? There's a lot of grass, there's a trench or a ditch of water down that side, and here's that same yard when it's dry. So the ground falls towards the fence, the gravel is mainly on the other side of the fence, and the lay of the land doesn't look too bad. It looks a little bit muddy, a little bit mulchy down the back, but otherwise this is a fairly normal yard. The water drains away from this person's yard on this neighbour's side towards the fence line, and so far it doesn't look like too much of a problem from this side. So I haven't been to this site, so I'm going to use the quotes that the homeowner has already received to help us get a feel for what's going on and what the options are. So here's quote number one. It says, after attending this property to assess the stormwater issues, access the neighbouring garden to remove turf, excavate a trench along the entire length, supply 450mm stormwater pits evenly across the excavated area, and install geotextile cloth to the base and sides of the trench. So this is a 30-metre long trench with 4 stormwater pits, ag pipe, penetration into the stormwater pit, install ag line through to this point, install 20mm aggregate to the base of the trench to within 100mm of the surface, and lay geotextile cloth over the top and then turf over the top of that. It's going to be laid on the neighbour's side and it's going to be covered back over with turf. So there's a couple of things going on here. The rocks and the ag line are all a good idea, but they're going to be buried underneath the ground and there's going to be turf back over the top. If the water is mainly in the ground, this isn't a bad option, but it looks like some of this water is in the surface. So getting the water from the surface into the pipe, into the council drain, bit of a way for the water to go. It's got to soak through the rock, through the turf on top, into the pipe, all the way to the council pit. And then we're hoping that the council pit doesn't have more water than it can handle and the water doesn't come back up the ag line. This is something we've discussed before. So this is an option. This is a typical option for taking water from below the ground that's already in the ground and taking it away. I'm not sure that this is the right option for us just at the moment. So let's see what the second option is. Attend site to remove the rocks, store on site, dig out the dirt from the tree to back fence between fence and retaining wall. So this is in behind the rock retaining wall that we saw. This one. So then they're going to core flute along the retaining wall to retain the water, lay slotted pipes behind the retaining wall, run it through to a pit in the stormwater easement, which must be at the back of the block, fill the trench with aggregate to 50mm below the top of a retaining wall to stop groundwater passing over the top of the rocks, reinstate decorative rocks above aggregate. So in this case, we're at least working on the homeowner's side. They can maintain this and look after their own drain. It's for their benefit after all. It will be underneath rocks which are porous, so the water that's flowing through the rocks and sitting on top of the rocks is going to find its way into this pipe and run into through an ag pipe down to the back boundary. So not a bad option. All right, so we'll remember quote number 2 wasn't too bad. Okay, so this is quote number 3. They've got a few parts to the quote. They've got drainage behind the retaining wall to excavate 2 trenches behind the retaining wall. One trench to be about 10 metres long. This will be 100 mil slotted socked ag drain. Carry water away from the wall, terminate into neighbouring council easement, which is the legal point of discharge. Trench to be backfilled with 20 mil blue metal, so 20 mil stone, and topped with the existing pebbles. So similar to quote number 2, second trench to be approximately only 3 metres long. We'll have 100 mil slotted socked ag drain, carry water from behind retaining wall, terminate into a stormwater pit as discussed with the owner, trench to be backfilled with stone. Then they're going to also cut the concrete next to the ag wall, install stormwater channel, drainage to terminate in 2 existing pits along a path at both ends as discussed. And then finally, they're going to disconnect the hot water system, remove the concrete, install new concrete mesh and pour a new slab with the correct fall, reinstate the hot water service, reinstall the air conditioner. So this one's identified that the slab doesn't have the correct fall on it. Now we'll just go with quote 4 and see what that looks like. Excavate the soil and unwanted materials. Install ag line from the golden cane palm flowing for the length of the stone wall, emptying into existing stormwater sump on the adjacent block. This ag line will have an exposed end for future flushing, so that's an important thing to finish an ag pipe back up at ground level so you can run a hose into it and clean it out and flush it out. It will be covered in 20 mil gravel with a layer of geofabric separating this level from the top section, which will be steel reinforced concrete spoon drain. So here we have a concrete spoon drain going over the ag pipe. This will be happening in the space between the retaining wall and the fence. Concrete spoon drain will sit on top of the ag drain, will be a minimum of 100 mil thick, will cover the whole area between the stone wall and fence. So similar to quote 3, they're doing a ag pipe and a spoon drain on top of that low rock retaining wall, and looks like they're doing a graded drain at the bottom of that retaining wall. So now the things I've got to ask is, is there a lot of leaf litter and material in here that's going to block up a graded drain? Right now, it's looking pretty neat. As long as the stones stay on the stone side of the retaining wall, the path looks pretty good, doesn't it? There's not a lot of leaf litter. There's maybe some plants around in the background, but we're not getting a lot of leaf litter. Have a look though over on the neighbour's property. There is a little bit of potential here for some of that leaf litter to find its way over the retaining wall and into the graded drain. So on that basis, I'm tending to think that a graded drain isn't necessarily the best option. Going back to this concrete slab, I'm interested to find out whether or not that slab does actually fall away from the house or if it actually grades back towards the house. Even with this photo, we don't have a good clear indication. Maybe the slab is a little bit higher in the corner where the hot water system is sitting against the house. It's hard to tell, it really is hard to tell. In any case, something is stopping this water from getting out from this area. And in my mind, this area isn't free draining. The water doesn't even look like it's moving anywhere. My biggest question for the homeowner in this case is, what is stopping this water getting away? What is holding this water in this area? Can that be undone? If it's a garden bed, can that bit of garden bed be removed? If it's the fence at the front of the block, is that what's stopping the water getting away? Find out what's stopping this water from getting away, and let's start by removing that. Then we can talk about spending money on spoon drains and ag pipes and cutting slabs and improving slab fall. Our first option is the cheapest and the easiest option, and it's pretty much the same as when we're playing as kids at the beach and we wanted water to go into the moat around the sandcastle. We cleared a way for the water to get in there. This is the opposite. We're clearing the way for the water to get off this concrete. What's stopping it? How can we improve that? So there you have it. 4 legitimate ways of solving the same drainage problem. We prefer to go for the cheapest and easiest first, and if that means that the obstruction can be removed from the water flow path, and that solves the drainage issue, then that for us is our point of call. But each of those options, each of those quotes has done a good job of identifying what the problem is and coming up with a solution. Spoon drains, grader drains, ag pipes, they're all part of a drainage solution. Different options have different amounts of maintenance and different amounts of care, and in general we prefer spoon drains where we can get away with it. So the actual answer for this job depends really on a site inspection, the amount of money available in the budget, how much the homeowner, how the building is being affected by the drainage issues, and how urgently they need to be addressed. I'm Matt Cornell from Cornell Engineers, and we've been talking about drainage and how to solve this case studies problem. Hope you have a great day.